Okay, so we're going to look at question 1 from the exam, and question 1 deals with factorising. Now, if you remember, there are three types of factorising. There are trinomials, the difference of two squares, and the highest common factor. And for every question, we have to make the decision which one are we dealing with. So the first question, question 1, part 1, you dealt with was 2x squared plus 3x. Now, let's make our decision. We know it's not a trinomial because there aren't three parts. So tri means three, trinomial means three parts. There are not three parts, so we can't use that. Now, is it the difference of two squares? Well, first of all, it's certainly not a difference because a difference indicates a subtraction. Ours is a plus, so it's not a difference, and it doesn't have two squares. X squared is the only square, but we can't write 3x as something squared. So that leaves us as highest common factor, so that's what it must be. So to do a highest common factor, we look at both terms and we pick out what's common. Now, looking at the numbers first, this has got a 2, this has got a 3, so there's nothing common there. But looking at the letters, they share an x. They don't share an x squared because this guy doesn't have an x squared, he only has an x to give, so they only share an x. We do our brackets, and what's left? Well, here you've just got 2x left, and over here you've got plus 3. So that's our final answer, and what we've done is we've factorised. In other words, if we multiplied this by this, we get this back. Alright, so we'll look at part 2. Part 2 of the question is 4x squared minus 100. Okay, and again we'll go through the same process if we're not sure. We know it's not a trinomial because there aren't three terms, there's only two. It could be a difference of two squares. There is a difference, so it is a minus, and we have to look at, can we write both sides as a square? Highest common factor, it can't be unless it's only a number you take out. There's no x on this side, so we can't take out an x letter. So we're looking at a difference of two squares. So before we begin, we have to write both sides as a square. Now, on this side, only x is squared, so we have to write the entire thing as a square. So 4 is 2, x all to be squared. So if I square this, I get 4x squared back, which is what I had originally. I put in my minus sign, and can we write 10 as a square? Yes, we can. We can write it as 10 squared. So that's a matter of just knowing that 10 squared gives you 100. Now we've got our difference of two squares, and it's very simple. We apply what formula we know. We do the first term minus the second term multiplied by the first term plus the second term, and that's our answer, because if we multiply both these brackets together and work it out, we will end up back with this answer. So time to look at part 3, and part 3 looks something like this: 7x squared minus 36x plus 5. Now it should be obvious, or it should be beginning to be obvious, is that these are trinomials because there are 1, 2, 3 terms. So these guys are just for 2 terms, this is for 3 terms, and when we do, we draw our lines down. Now again, some people have different ways of doing this. This is the way I do it. I split this up into 7x and x. X by 7x gives me 7x squared, so I have to double check that. And on this side, I look at the factors of 5. Well, because 5 is prime, it's quite easy. It's 5 times 1, or it's minus 5 times minus 1. Now, look at the term that we're trying to find. We're trying to find minus 36x. Now, we're going to cross multiply here. So, if, for example, I try 5 and 1, let's see what that gives me. 5 times x is 5x. 1 times 7x is 7x. 7x and 5x is 12x. That is not what we're looking for. So 5 and 1 just won't do. So cross them out. Now we could swap places and try that. Let's put the 1 there and the 5 here. 5 times 7x gives me 35x, and 1 times x gives me x. 35x and x gives me 36x. Now, don't be tempted to think that's the right answer because we're looking for minus 36x. So we know the numbers are right, but the signs are wrong. So that's okay because we know that another set of factors of 5 are minus 5 and minus 1. So if we simply put a minus on both of these, let's double check. Minus 5 by minus 1 does give me plus 5. because a minus by a minus gives me a plus. And let's cross multiply. Minus 1 by x is minus x, and minus 5 by 7x gives me minus 35x. Minus 35x and minus x does indeed give me minus 36x. Make that look more like an x maybe. So that's our answer, and remember when we're reading it off, we read it across the way. So our two brackets are 7x minus 1 and x minus 5. And that's our solution. So if we multiply these two brackets together, we'd end up back having this. So these brackets are the factors of this term. Okay, question 2. Now question 2, we're asked to solve this equation using the minus b or the quadratic formula. So I've put the quadratic formula over here for you. Now when it says solve a quadratic, it actually means find out what x is. So it's going beyond factorizing it. It means find out what possible numbers we can use for x to make this equation balance. Okay, so to begin the quadratic, we have to start off by identifying the letters a, b, and c. So a is always the number in front of the x squared, b is always the number in front of the x, and c is always the number or the constant on its own. So a couple of things to just be careful with there. First of all, we're not interested in the x squareds or the x's, so they're not included in the a, b, and c. They're gone, okay? So we forget about those for a little bit. And the second thing you need to be careful of is keep the sign. So a lot of boys, they write down b is equal to 5. B is equal to minus 5. C is equal to minus 12. So you have to be careful, and I'd always advise writing these down first. Let's kick off with our formula. So x is equal to minus 5. So use brackets, minus b, and that's minus 5, plus minus square root of minus 5 squared, again using brackets, minus 4 times a, which is 3, and c, which is minus 12, all over 2 times a, which is 3. Now, at this stage, it's good to be able to practice it, but it's also important to use a calculator so that you avoid making any mistakes. But here, just watch out. Minus 5 gives you plus 5. Plus, minus. Now, if you enter this correctly into your calculator as it is, including all the brackets, you should end up getting 169 all over 6. Now, the square root of 169, I happen to know, is 13. So you've got 5 plus 13 and 5 minus 13. They're your two options. So you've got x is equal to 5 plus 13 over 6, or x is equal to 5 minus 13 over 6. So we can conclude that x is equal to 18 over 6, which is 3, or x is equal to minus 8 over 6, which is minus 4/3 when we simplify it. Now, what does that exactly mean? Well, that means if I take 3 and I put it into this equation instead of x, that'll balance, it'll give me 0. And if I put minus 4/3 into this equation, it'll also give me 0. So let's just check the 3. 3 squared is 9, multiply it by 3, you get 27. 5 threes is 15, and 15 minus 12 is minus 27. That is 27, so 27 minus 27 does indeed give you 0. Question 3 is all about surds, and it's all about simplifying surds. So there's just some basic rules we're going to need to know. So if we look at the square root of 32, which is the first part, there is no square root of 32, or at least there is no even square root of 32. But what we can do is we can split 32 up into the square root of 16 multiplied by the square root of 2. Why? Because 2 16s give me 32, and this is the rule of surds. Now there might be other combinations that you could use, 8 divides into 32 and so on, but as long as you follow the rules you'll always get to the right answer, whether you go a long way or a short way. The square root of 16 is 4, and the square root multiplied by the square root of 2. Now we can't simplify this down anymore without making it a decimal. Okay, so that is our answer. Look at part 2. It's the square root of 27. Now again, there's no even square root of 27, so we can break it down. Now some factors are 9 times 3 give me 27. So if I wrote the square root of 9 times the square root of 3, and the square root of 9 we know is 3. So it's 3 times the square root of 3. Again, we can't break that down any further, so that's our answer. And for the final part, it's square root of 54. Now there are different factors here you could try out. The one that's easiest to deal with is the square root of 9 by the square root of 6, and this might take some guesswork to get this right. 9 sixes do give me 54. The square root of 9 is 3, and we can't do anything more with the square root of 6. In other words, if we broke down that square root of 6 any further, it just won't give us anything nicer. So that is our final answer. Okay, question 4. Question 4 is an unusual question. It gives us the roots of an equation, and it asks us to find what equation has these roots. So it's like a quadratic equation backwards. So we'll actually just do our steps backwards. So we would normally have found the roots, and that means that x is equal to minus 3 or x is equal to 4. Now I can take that minus 3 across and it becomes a plus 3, and I can take that 4 across, that's a minus 4. Now if this is equal to 0 and this is equal to 0, well then if I multiply the two of them together, I should still get 0, because 0 by 0 gives me 0. So multiplying the two of them together should still give me 0. Now these brackets need to be multiplied together, so just in case you don't know how to do that, here we are. So we multiply each term on the top by each term on the bottom. So x by x gives me x squared, x by 3 gives me 3x, minus 4 by x gives me minus 4x, and minus 4 by 3 gives me minus 12. So that is x squared plus 3x minus 4x minus 12 is equal to 0. And just to simplify that down, that's x squared, 3x minus 4x is minus x, minus 12 is equal to 0. So this equation has these roots. Okay, so question 5. Question 5 is a more difficult question, and we're asked to solve for x and y of the equations x plus y equals 3, which we should recognize as a line, and x squared plus y squared equals 17, which is actually a circle. So it's not like a typical simultaneous equation with two lines. This time we're trying to find where a line meets a circle. Now, a line might not meet a circle, it might meet it once, or it might meet it in 2 points. Those are 3 possibilities. Okay. So what we do is we take, we'll call it A, the line. We'll call this guy B. We take A and we rearrange it. So we make x equals the rest. Now you could make it y equals the rest. So what we're saying is x must be equal to 3 minus y. So if x is equal to 3 minus y, that means over here in B we can say 3 minus y to be squared plus y to be squared equals 17. We've replaced x with 3 minus y. Okay, so to work out this equation, we're going to have to get rid of this bracket. Now this bracket is 3 minus y multiplied by 3 minus y. 3 3s are 9. 3 by minus y is minus 3y, minus 3y again, and y squared. So you can check that yourself just to make sure they're all correct. So that gives us on the side of b, you've got y squared minus 6y plus 9 plus this other y squared is equal to 17. So that y squared is here, that gives me minus 6y, and that's 9, so that's that bracket squared. And then I've also got this y squared, and I've got equal to 17. So if I rearrange things, y squared and y squared gives me 2y squared. You've got minus 6y, and if you take away 17 from both sides, you'll be left with minus 8 is equal to 0. And what we have here is a trinomial equation. Okay, so before I try and solve it, I can divide everything by 2 because they all divide by 2, and that gives me this, which just makes life that little bit easier for me. So now I have to factorize this. Well, if I do down my lines and split that into y and y, do that in the line here, Now if I write that as minus 4 plus 1, minus 4 by 1 gives me minus 4, so that's okay. Y by y gives me y squared, so that's okay. Cross multiply these and you've got 1y minus 4y gives me minus 3y. So this is correct. So my answer is y plus 1, y minus 4 must be equal to 0. Now, if these two are equal to 0, that means that is equal to 0 and that is equal to 0. So therefore, we get y is equal to minus 1 and y is equal to plus 4. Okay. Now what we've found is we found the y components of the places where these two meet. So we found where y is, but we need to find what x is. Now obviously if there's two y answers, there's going to be two x answers. So we'll go over here. Now what we'll do is we'll take a again and we'll say x plus y. Now instead of writing y, I'll take minus 1. So x plus minus 1 is equal to 3. That's x minus 1 is equal to 3. So x must be equal to 3 plus 1. So x must be equal to 4. So that pair that we created is x is 4 and y was minus 1. Okay, so we're happy with that. But we've got a second y, which is 4. So we need to use that as well. So we go back to a again and we say x plus y is 4 is equal to 3 also. So x must be 3 minus 4. So x is equal to minus 1. Now, that means that this pair is minus 1 and what did we say y was? 4. So, our two answers. This point and this point is where this line and this circle meet. Question 6. Question 6 is an indices question. And it can be tricky, so just take your time with them. Make sure you do each thing step by step, okay? So we're asked to write the following as a power of 5, okay? So we're given the square root of 5 over 25, all to be squared. So we'll start inside the bracket and see what we can do. So we're trying to write everything as 5 to the power of something. Okay, so my first step would be write that as 5 to the power of half, which is one of the rules we know. And that's written as 5 squared. So 25 is the same as 5 squared, and the square root of 5 is the same as 5 to the power of half, and don't forget we've still got all to the power of 2. Okay, so inside the bracket there now you've got a division, and so the rule for division is we take the bottom one from the top power. So we keep the base, which is 5, and we take this one from this one. So we've got that inside the bracket, all to the power of 2. Okay, so a half minus 2 gives you minus 1.5. Okay, so in other words, way of writing that is minus 3 over 2. And finally, we've got inside the bracket sorted, which is to finish outside the bracket. When you've got a power outside a bracket and a power inside a bracket, we multiply. So that's going to give me 5 minus 6 over 2. And that is the same as 5 to the power of minus 3. So we've written this first term as 5 to the power of something. So this is the same as this. Now, part 2. Part 2, we're dealing with to the power of 2, okay? So we've got the square root of 8 all over 2 to the power of 2. Okay, so we'll start similar again. The square root of 8 can be written as 8 to the power of a half all over 2 squared. Now we've got a problem here. Normally, like we did over here, we took, once we got them into powers, we took the bottom one from the top one. But here we can't do that. And the reason we can't do it is because the bases are different. So we need them all to be 2 to the power of something. So 8 is 2 to the power of 3. So if I replace 8 with that, I'll explain to you what I've done. So 8 is 2 to the power of 3. 2 by 2 by 2 gives me 8. So it's to the power of a half. So all this to the power of a half. We haven't touched the bottom, haven't touched this power. So now in this bracket, we multiply these. So you've got 2 to the 3 over 2, which is 1.5, all to be squared. Now this 2 in bottom, what's it to the power of? Well, it's to the power of 1. Always. So any number is always to the power of 1. So now that we've got our fraction, we should be taking this number from this number. So it's 2 to the 3 over 2 minus 1, all to be squared. Well, that's 1.5, and if you take away 1, you've got a half. So it's 2 to the power of a half, all to be squared. And again, we've got the brackets sorted, so now we do these, multiplying them. So 2 halves is 1, so you end up with 2 to the power of 1, which is the same as 2. So these are all just equal to the next line. So 2 to the power of 1 is equal to 2. So this is the exact same as just 2.